Okay, now let's solve a polynomial equation. Let's use Descartes' rule of signs and synthetic substitution to find all of the zeros of the following functions. Okay, the first one here is a third-degree polynomial. So let's go ahead and do our Descartes' rule of signs scenarios first. Let's go ahead and make our table over here. We're going to have, let's see, positive reals, negative reals, imaginaries, and our total. Okay. Now let's count our sign changes. Oh, having a little trouble here. All right, here we go. Sign changes. For positive reals, let's count sign changes. We start off with a positive to a negative. There's one sign change, another sign change, and that's it. So that means we have either 2 or 0 positive reals. All right, now let's look at replacing x with negative x. Okay, negative x cubed minus negative x squared plus 2 times negative x plus 4. Let's simplify that, and we get negative x cubed. The negative x squared, the negative goes away, but then there is another negative there. Be careful with your signs. Minus 2x plus 4. Okay, now let's count sign changes. There is only one right here. All right, so that means there's only one negative real. So let's finish off our chart. There can only be one in this column. So our scenarios are 2 positive reals, 1 negative real. Our total is 3 because it's third-degree polynomial, so there would be no imaginaries in that scenario. The other scenario is there could be 0 positive reals. Again, there can only be 1 negative real. And since it totals 3, in that scenario there would be 2 imaginaries. Okay, now, next, let's use synthetic substitution to try and find the solutions. Well, how does this help us? How do we know where to start? Well, if you look at the second scenario, there could be no positive reals. So it would be a good idea to not start with positive reals because there might not be any. So let's try negative reals and see if we can't find one. So let's start with an obvious choice. Let's go ahead and, oops, let me erase that. Let's start with negative 1. All right, so here we go. Synthetic substitution, let's use negative 1. Let's use our coefficients from our original polynomial, 1, negative 1, 2, and 4, and do our synthetic substitution. There should be a negative 1 right there. Okay. I'm going to try negative 1 first. So synthetic substitution will give us a negative 1 here, add negative 2, a positive 2 here, add, you get a 4, negative 4 here, add, you get a 0. Well, we got lucky. We got a 0 remainder, which means negative 1 is a solution. So we found one of our solutions. Now, our depressed polynomial, 1, negative 2, and 4, right here, those are the coefficients of our depressed polynomial. X squared minus 2x plus 4. If you notice, that's a quadratic equation. Okay, those can either easily be solved either by factoring or using the quadratic formula. Okay, well, we found one of our 3 solutions. That is not factorable, so let's put that into the quadratic formula to solve. All right, so negative b would be negative negative 2 plus or minus the square root of b squared, which is negative 2 squared minus 4 times a, which is 1, times c, which in this case is 4, all over 2a, which is 1. Okay. Let's simplify this. This equals 2 plus or minus the square root of negative 12 all over 2. That can be simplified further as x equals 2 plus or minus 2I radical 3 all over 2, which equals, that can be simplified down to 1 plus or minus I radical 3. There's our two imaginary solutions. Our other solution was negative 1 because it gave us a 0 remainder. So there's our three solutions: negative 1, 1 plus I radical 3, and 1 minus I radical 3. So how did how did Descartes' rule of sign help us here? Well, it helped us narrow down right away which numbers to try using synthetic substitution, because in the second scenario there was no positive reals. So we decided to just try negative reals, and we got lucky. The first one we tried was negative 1. All right, the second example, pause this video. You guys try this second one on your own, and we'll go over it in class. Thanks.